Okay, here is some of the probability rules. You can pause the video and write all of this down if you want, and then you can go ahead and continue it again, and you can hear me talk. Okay, so remember that some of the probability rules that you're going to be working with is the word or and the word and, right? If you have the word or, that means that you're going to have to use the addition rule. I wrote down the addition rule here. Remember that the probability of A and B are going to be given. This thing is also going to be given to you. So you do not need to calculate this. So whenever I have a problem that says the word or, just go under the assumption that I already gave you A, B, and A and B. A, B, and the probability of A and B. So this is already given to you. You don't need to calculate it. Do not use the multiplication rule because that's a wrong thing to do. Okay, so that's for or. Just add and then subtract the intersection. Okay. If you see the word and, right, if I'm looking for the probability of this and this, use the multiplication rule by multiplying probability of A times the probability of B given A. Usually these types of problems will be the replacement ones, the ones where you replace the marble and all that stuff, right, where you replace. Or you can also use common sense, because usually a lot of these problems, you don't really need to do any math. You can just probably think about it and just assume what the probability is going to be. And just listen to your gut most of the time. If you don't use a formula, that's going to be fine. Because I know that some of them, you can go ahead and just think about it and it's going to come to you. But there's certain problems that, you can't quite do that. But anyways, that's really what I would just go ahead and recommend if you can't follow these formulas. Okay, a little bit of a warning. The probability of two disjoint events is 0. So remember, two disjoint events are events that can't happen at the same time, right? So you cannot get a 2 and a 4 on one roll of a dice, right? So the probability of A and B equals 0. So just be very careful with that. Okay. If you see the word if or given that, remember that that's conditional probability, and that all you're doing is just restricting the sample to what we already know. So if I randomly select a person and I know already that they're female, that's going to change the probability, right? Okay, and we'll do some problems like that in class this week. Independence, the only thing that you need to know is that you will only use this formula. You will need to prove that two things are either dependent or not independent using this formula. Remember that we need to make sure that this side equals this side. Okay, so they both have to equal. I wrote this down here. Keep in mind that when you're solving probabilities, whether they're binomial, normal, or these types of probabilities, your probability always has to be between 0 and 1. So if you get a probability of 1.2, I'm going to give you no points, because you need to know that probability always has to be a number between 0 and 1. And if you get something that's greater than 1 or a negative number, you know you did something wrong. Okay, so that's what I would recommend. I will double dock you points if you give me a probability that is not within this range. Okay, here are some other formulas, some FYIs, right? The expected value of a probability distribution, right? X times probability of X, and the sum, standard deviation. These formulas I would recommend for you to go ahead and put them in your cheat sheet also. Okay. Also remember that random variables can either be continuous or discrete. Continuous means that you can choose any possible number, decimals, fractions, whatever you want. Discrete means that you can only have whole numbers, right? So 0, 1, 2, 3, whatever, okay? An example of a discrete random variable is binomial distribution, right? Continuous is something that's normal. Something else that I can think of is maybe weight, right? Weight, you can weigh 102 point whatever. Binomial, something that you can, siblings, right? You can't have a third of a sibling, right? Okay, and then what I want to do now, I just want to start you off on one particular problem. So I'm going to go to the practice exam, right? And I'm going to go ahead and start on number 2, right? So I'm going to start you off because that one can be a little bit difficult if you don't really know what you're doing. So basically what this says is that Catherine typically gets 2 types of alcoholic beverages at the bar. She will either order a Midori Sour 40% of the time or order an AMF. After her first drink, Catherine can either decide to get to order a water or another alcoholic beverage. If she orders a majority sour, she decides to get a glass of water 20% of the time, and if she orders an AMF, she tends to order a glass of water 55% of the time. Okay, you read that and you're instantly confused. So how do you go ahead and do this problem? Okay, so let me go ahead and guide you with this. The way that I'm going to do this is with a tree diagram, because I think this will probably help out a little bit. Okay, so what I would say first when you see this type of problem, I know that there's two different types of things that Catherine can get. She can either get a majority sour, right? I'm just going to write it as M, or she can get an AMF, and I'm going to label that as A, okay? So she will either get a majority sour 40% of the time, right? So this is just 0.4. So this is 0.4, assuming that she can only get those two, AMF must be 0.6, okay? Now what happens? After she takes her majority sour, she can do one of two things, right? And basically what I'm drawing a tree diagram to kind of label out all my events, okay? So let's see. If she orders a majority sour, she decides to get a glass of water, so she gets water only 20% of the time, so 0.2. So that means she'll get another alcoholic beverage, right? Alcohol, right? 80% of the time, right? So it's probably more likely that she's going to get more alcohol. Whereas if she orders an AMF instead, right, she will get water 55% of the time. Okay, so that means that she'll get more alcohol only 45% of the time. Okay, does everybody see what I did? So this was when there's a lot of things going on, what I would suggest is try to do some sort of tree diagram, because that's going to really, really help you. Okay, then I'm pretty sure you can do this problem. What is the probability that she orders an AMF first and then a water? Well, AMF first is here, right? And then a water. The key word is and, right? So what are we going to do with these two probabilities? Multiply them together. So multiply these two and you should get your answer. Okay, so hopefully this helped a little bit on solving some of your problems. And yeah, so let me go ahead and exit from this. And if you have any questions, I'll go ahead and answer them on Monday, or you can feel free to email me.